A blank time bar slot looks simple, but it is operationally ambiguous. What you need is not a made-up candle. You need to know whether to remove the slot from the expected grid, recover missing source messages, rebuild a bar from independently captured trades, or stop because the evidence is not trusted enough to act. For a practitioner, that keeps returns, volatility, and monitoring clean. For the engineer or analyst building the pipeline, it turns a visual gap into a reproducible diagnosis with retained proof. That is what the Missing-Bar Gap Classifier is designed to do. The Missing-Bar Gap Classifier builds on time bars and exchange calendar alignment. A time bar owns a half-open interval. Its start belongs to the slot, and its end belongs to the next one. Exchange calendar alignment decides, from a versioned venue schedule, whether that interval was expected at all. Here, we add bar observation, authoritative halt status, transport health, sequence continuity, and independent trade activity. You will learn to produce all 8 terminal classes, preserve unknown and conflicting evidence, calculate the 78-slot closure example, implement the same audit logic in Python and TypeScript, and verify it against shared fixtures. The boundary is just as important. The classifier diagnoses absence. It never invents a price or silently authorizes repair. At its core, this classifier asks 5 different questions in strict priority order. First, is a validated bar already present? Second, does the versioned session calendar include this slot? Third, does authoritative market status evidence show an active halt? Fourth, was the source transport healthy with no lost heartbeat and no sequence gap? Fifth, did a source independent of the missing bar path observe trades? Exchanges publish calendar information separately from halt information, and sequenced feeds expose transport continuity separately again. Those facts justify distinct layers. They do not dictate this ordering. The precedence ladder is an explicit conservative policy. In the simple 1350 example, the session is open, no halt is active, transport is healthy and continuous, and an independent source reports no trades. The ladder reaches the 5th layer and returns inactive. A Boolean, such as halt false, is too small for this job. It cannot tell you whether the halt feed was checked, late, unavailable, or contradicted by another retained source. Each layer, therefore, has 4 epistemic possibilities: known and affirmative, known and negative, unknown or conflicting. Unknown means the required evidence is absent, late, or not observable. Conflict means sources disagree at the same layer. Neither state is treated as false. Independence adds one more guard. If feed A is the path that failed to build the bar, then 0 messages on feed A cannot prove that the market was inactive. Only healthy transport plus activity evidence independent of that path can earn the inactive class. For each candidate slot, the input contract requires 6 categorical states: bar, session, halt, heartbeat, sequence, and activity. It also requires a literal independence flag and at least one immutable evidence identifier. A production record should carry instrument and venue, the event time interval, receive and availability times, feed session, calendar version, correction version, and classifier version. The output is an audit record, not merely a label. It contains the classification, the decisive layer, a plain language reason, copied evidence identifiers, and warnings. The 8 terminal classes are present: closed session, expected halt, feed outage, inactive, bar builder error, unknown, and conflicting evidence. Notice the missing field. There is no synthetic price. Classification happens before a separate repair policy. Now traverse the complete decision ladder. A present bar returns present. Unknown bar presence returns unknown. For an absent bar, session conflict returns conflicting evidence. Unknown session returns unknown. and a closed session returns closed session. If the session is open, halt conflict or unknown remains explicit, while an active halt returns expected halt. Next comes transport. A conflicting heartbeat or sequence state is quarantined. A lost heartbeat or sequence gap is positive evidence for feed outage, even when activity is unknown. If neither fault is positive, but continuity is incomplete, return unknown. Finally, activity conflict or unknown remains explicit. Dependent activity returns unknown with a warning. Independent no trades returns inactive. Independent trades with no bar returns bar builder error. The rule is conservative. Unknown at a stronger layer stops descent to a weaker story, and a conflict is never settled by whichever source arrived last. These three in-session slots look identical on a candle chart. The difference lives in evidence, not geometry. At 1350 UTC, the bar is absent. The session is open, no halt is active, heartbeat is healthy, sequence continuity is intact, and an independent source reports no trades. The classifier reaches activity and returns inactive. At 1420, the visible states are the same, but the zero trade observation comes from the missing path itself. Independence is false, so the result is unknown with a warning. At 1425, one retained calendar version says open and another says closed. That session conflict returns conflicting evidence immediately. Healthy transport and zero activity cannot decide whether the slot belonged in the expected universe. The historical case keeps four layers separate. First, sourced fact. On December 1st, 2018, ICE and NYSE announced that the named NYSE group markets would be closed on Wednesday, December 5th, for the National Day of Mourning for President George H.W. Bush. Second, provider observation. None. This package did not query or license any vendor's historical bars, so it makes no claim about vendor behavior. Third, engineering assumption. Compare that official closure with an intentionally naive weekday template from 9:30 to 1600 New York time, divided into 5-minute half-open slots. 6.5 hours times 60 minutes divided by 5 minutes per slot equals 78 candidate slots. The official closure produces 0 expected slots. The interpretation is one calendar model defect, not 78 feed failures. With the closure notice attached, every naive candidate stops at closed session. This demonstrates calendar diagnosis, not provider accuracy, prices, or economic impact. Both implementations follow the same pure pattern. First, validate every enum, require a literal Boolean for activity independence, and reject empty evidence identifiers. Next, evaluate the precedence ladder without mutating the input. Return immediately when a layer becomes decisive. That makes the stopping rule visible in code and prevents weaker evidence from leaking into the result. Every return builds the full audit record and copies the evidence identifiers, so downstream callers retain lineage without sharing a mutable list. Python exposes diagnose gap for the record and classify gap for the convenience label. TypeScript exposes the equivalent diagnose gap and classify gap functions. In an audited production pipeline, keep the full diagnosis. Across n candidate slots, the work is linear time, and the retained outputs use linear space. Each individual slot needs constant working space. The interactive lab and shared fixture challenge the same deterministic state machine. Canonical cases reach the 6 confident outcomes. Unknowns. Stop where required evidence is missing or dependent. Conflicts stop where retained sources disagree. Step and back move one decision at a time. Play, pause, and reset use. That same transition and reduced motion mode turns play into one deterministic step. The shared fixture contains 15 meaningful states, not a long run of repetitive normal bars. Python and TypeScript tests verify all 8 terminal classes, exact fixture parity, decisive layer and lineage preservation, positive feed faults with unknown activity, stronger unknowns blocking weaker no-trade claims, dependent zero activity staying unknown, invalid field failures, and the exact 78 slot derivation with provider observation still null. Passing proves agreement with this package's definition. It does not measure live cause frequencies or authorize a repair. Production shortcuts can quietly turn uncertainty into certainty. Boolean unknowns erase whether evidence was absent or checked. Calendar drift changes old expectations when today's calendar replaces the version known then. Dependent activity evidence uses the failed path to prove its own silence. A healthy heartbeat proves only connection state. Sequence continuity is still a separate question, and a sequence gap does not reveal which economic events were lost. Halt records can arrive late or be corrected, so availability time must produce a new point-in-time diagnosis version. Consolidating venues before diagnosis can hide a single venue outage, and repairing before preserving the cause destroys auditability. Keep instrument, venue, feed session, calendar version, correction version, classifier version, and evidence identifiers attached. The stable diagnosis may be revised when new evidence becomes knowable, but the earlier version must not be silently overwritten. You can now distinguish an observed bar from an absent interval, apply a strong to weak evidence ladder, preserve unknown and conflicting evidence, prove inactivity only with an independent source, retain audit lineage, and verify the same behavior in Python and TypeScript. Keep repair in a separate field and workflow. Closed session can remove a slot from the expected grid. Feed outage can trigger message replay and reconciliation. Bar builder error can trigger deterministic reconstruction from validated trades. Unknown and conflicting evidence should block automatic repair unless an explicit risk policy says otherwise. A missing bar is a question, and this classifier answers only as strongly as the retained evidence allows. Next, feed latency monitor distinguishes data that is absent from data that has merely not arrived yet. Continue with feed latency monitor, source code, and the complete visual learning path at thefintechbuilder.com.